So in this presentation on electromagnetic waves, give a very brief explanation as to why the sky appears to be blue, and also talk a little bit about thin films, which is something that occurs due to interference of electromagnetic waves. So when we look up into the sky, oftentimes the sky will appear a very deep blue, and other times it will appear sort of like a muted white color. And then even at sunset, it might appear to be red or orange or something to that effect. So we know that the Earth is bombarded by visible light, and that visible light makes up all of the visible light spectrum, red, green, blue, and all of those colors in between. So here we have, in the top picture here, we have all of the colors, right? The visible light, the sun's light that's coming and reaching the earth. And so what happens is that when sunlight hits our atmosphere, that it scatters. And it, this scattering occurs because the light interacts with the atoms that make up the atmosphere. And nitrogen and oxygen make up a lot of our atmosphere. And these atoms of nitrogen and oxygen behave as tiny tuning forks, if you want to think about it that way, and they react to the energy in the sunlight. So they're sort of attuned to the range of visible light that's in the violet and the blue region of light. And so what happens is that when the light enters the atmosphere, you get this vibration of the atoms, and it causes the atoms of nitrogen and oxygen to get excited. And when they get excited, they emit another photon. And the photons that they emit are in a very discrete frequency range, which is in the range of the blues and the sort of this violet range. Violet is actually scattered the most by nitrogen and oxygen, and then blue, and then after that comes green, yellow, and orange. So in the upper atmosphere, you have all this scattering that's going on because the light is interacting with these atoms. These atoms they're vibrating, they're getting a little excited, they're emitting a photon, and when they emit that light, it comes out as blue. And so that's why we will see the atmosphere appear to be very blue in color. When there's low moisture in the air, the sky appears very bright blue. When there's a lot of dust particles in the air or moisture in the air, the sky will appear more whitish. And if we look towards the sun, we actually will see colors that are not necessarily blue. It will see more of the reds and the greens, which mix together to sort of give us that yellow color. Because of course the blue has scattered away, and we've got, what's left behind, which is the colors of red and green mixed and give us that yellow color. So sunsets, on the other hand, are often a very pretty red or orange or yellow color. And that's because those colors of light scatter the least. And so if you think about what's happening in the middle of the day, the sun is directly overhead, and it passes through some of the atmosphere, and you've got a lot of scattering of the blue light because that light is interacting with our atmosphere. But at sunset, when the sun is lower in the sky, that light has to pass through more of the atmosphere to get to the person. So when it's directly above, it passes through a certain amount of the atmosphere. But at sunset over here, it has to pass through much more of the atmosphere. So more scattering can actually occur, and we've scattered away a lot of that green color. And so what's left behind is the red color that we would see at sunset, and some of the orange. So there's still some green light that's sort of mixing, and we get some of that orange color as well. The thicker the atmosphere is, the more chance there is to scatter all of those high frequencies away, and what's left behind are the lower frequencies, which are the lower frequencies, which are the reds and the oranges. So the sky appears blue, not because there's actually blue light up there, well, there is blue light up there, but it's because of the fact that the atoms up there are actually interacting with the light, and they're producing this blue light from this interaction, and it's called scattering. Diffraction is actually the bending of a wave around a particular opening, and there's a nice PhET simulation for that. I'm not really going to talk about diffraction. It is kind of an interesting thing to see, but let's just talk for a minute about thin films because it's something that you do see frequently. So thin films are essentially just a very thin amount of a substance that's over top of another substance. So it could be a small layer of water that's on top of a piece of glass, for example. Or this is a great picture right here because we've all seen this before, where on a rainy day you might have a spot that there was some oil on the ground and then some water was on top of it. So you have a thin layer of oil and then another thin layer of water, and those are thin films. A bubble is also a thin film because of the fact that the bubble is made of, it's got some soap in it, and it's just a very, very thin amount of that substance. And then you've also got some things like bugs that can have this effect as well. Not so much because they're thin films, although, yeah, they probably do have these thin layers on them. This can also be referred to as iridescence. So, just to sort of see what's happening here, basically, when you have these thin films, you can get these different colored effects. So you almost get a rainbow effect on the bubble and also on this thin film here, which appears to be oil. And the reason that you get that is because of constructive and destructive interference. So again, we're not going to spend a lot of time on this, but just to give you a feel for what's happening, you basically have light, which is incident, which is coming in, and it's striking the top surface of this thin film. So here is the thin film right here. And when the light strikes the surface, one of these light rays actually hits the top surface and it reflects off, because you can have reflection off of the surfaces. Close to that, another ray of light hits the surface, passes through the surface, slows down a little bit, reflects off the next bottom surface, so the thin film is sitting on something else, reflects off, and then it starts to interact with the first ray that I mentioned here that reflected off. And one of the things that you should see here is that the light that was reflected from the first ray and the light that was transmitted and then passed back through the surface of the second ray, they are interacting in such a way that they are canceling each other out. This is destructive interference. So if there was a particular color here of light that was coming in, because they have a certain frequency, those colors would completely cancel out. While perhaps other colors coming in would actually add together, and that's how you can get this layered effect with these different colors. So you have destructive interference of a particular frequency of light, and then you can have constructive interference of others, and we see these different colors due to this thin film and this interaction of the waves. But it's really just the same thing we talked about before, which is interference of two different waves. It just happens to be light waves.